All right, guys, it's time to start scaring you with triangles that don't have 90-degree angles in there. So everything that you've learned about trigonometry, none of it applies here. Well, not all of it anyways. Now, it turns out that for all triangles, there is a relationship between the angle and the length of the side. Okay? Now, I believe I said once before that the angles are always in capital letters. Well, sides, the lengths are now in lower cases. So this actually did apply for regular 90-degree right triangles, but we really don't use it very often in that situation. Generally speaking, we use opposite, adjacent, and hypotenuse there. But in this triangle, those relationships don't work because there is no 90 degrees, there is no hypotenuse. So we had to come up with a different naming system. And like I said, it does apply for all triangles. We just tend not to use it for right triangles. So the sine law is sine of A equals over A equals sine of B over B equals sine of C over C. Um, it seems complicated. It actually isn't. What it's essentially saying is that the angle of B is related to the length of B. And we kind of knew this already. The biggest angle is always across from the biggest side. And that's essentially what the sine law is saying. It's, of course, making things a little bit more complicated because it's math and that's what we do, but that's essentially what it's saying. The reason that we have the sign in there is that it's not a direct relationship. There's gobbledygook that has to happen. So here's how it works. I have three relationships and I don't need them all. I have A and A, so I need that one. I have B and I'm looking for B, so I need that one. So I just go, I don't need that. It's gone. Bye-bye. I only use the four that I need. And I start filling in values. And this is where the difference comes important. It's a capital A, which means it's an angle. Now, again, all right, for the first one, I am not going to assume that your algebra skills are up to snuff. All right, so I have isolated AC. You could turn them all into numbers if you want and then have 3 times, I didn't even write it down, decimal, whatever the decimal is, divided by decimal, whatever the decimal is. And that's fine. But then you're writing out a whole lot of numbers and you're more likely to make mistakes. Whereas if you rearrange everything, you can put it in your calculator exactly like this, 3 times sine 71 divided by sine 63. Word of caution, you need to know your calculator because some calculators will do sine 71 divided by sine 63 as you mean it. Some calculators will treat it as sine and then 71 divided by sine 63 and then take the sign of that. So you got to be aware of what your calculator is doing. Unfortunately, I didn't build these calculators. Not every calculator is done correctly. And if you don't know what you're working with, you're going to make mistakes. And they're not even your mistakes. So if you're brave, give this one a shot. I guess I'm mixing and mingling my F and my EX, but it really doesn't matter. As long as you got the correct values in there. Okay, so essentially I've rearranged it. It's divide by 4, so I multiply by 4. I end up multiplying that in there, but then dividing by the sine 68. Or if you want, refer to the first example and you can see the full algebra to how I did it. Make sure I got the right one. There is no units in this one, so I can just leave it as 2.6. Quick thought. How do I know 2.6 is reasonable? Us math teachers are always big on double check your answer. I can't do that math in my head. I don't have the sine tables memorized, but I can go an angle of 70 gives me a length of 4. So an angle of almost a little over half of that should give me a little over half of 4. And 2.6 is a little over half of 4. So I don't know for sure that I haven't made a mistake, but the answer looks reasonable to me. All right. Now I'm going to do it pretty much as the minimum that I expect out of you. And really, I still don't need to see the step, but I'm showing it anyways. The next one, I'll give you exactly the bare minimum you need to have in there in order to get full marks. Okay, so once again, and remember, sine g is one value, so it all stays together. So we're isolating the sine g, solving it, so I put 15 times sine 40 divided by 25 into the calculator and got the decimal 3875. Now, if you can, just leave that in your calculator and then hit shift sign. And however many decimal places your calculator has, it'll calculate the answer. It'll actually be even more accurate than my answer is. All right, so the absolute minimum that I expect to see and still get full marks. Okay, so you don't have to show me the rearrangement. You do have to show me the substitution step. I don't have to see the rearrangement. However, because this step is kind of an in-between, I do want to see it. I don't need to see it, but I do want to see it. And then, of course, the final answer. Now, there's a scenario that we haven't looked at yet that's going to come up in example 3. Bicycle path forms a 66-degree angle with one lock of a canal. At a distance of 2.5 kilometers along the bicycle path, the angle separating this lock from the next lock is 52 degrees. How far apart are the two locks? So we're looking for this distance here. Now, here's where I get a little frustrated with trig. We need to know what this angle here is, right? We have our matching, but we don't have anything to match it up with. So technically, I have to have another value in there. I'm just going to solve for it. Oh, what is that? Huh. All right, sorry. Now I have all the information that I need. So sometimes you're going to have to solve for that third angle in order to solve the question. You're going to see in my solutions that I tend to write out what the rearrangement is. I don't know why. I don't do this for any other style of question, but I do it here. Okay, it's homework time. Make sure your answers are always right. Notice in this order. Your textbook does some goofy things with its questions, so I kind of try to fix it, but it means I have to do goofy things with my how I've laid out the homework. So do it in that order. Have a good one, ladies and gentlemen.